lecture, we're going to look at what's called slope-intercept form of a linear equation. So you may heard of y equals mx plus b form. Well, this is slope-intercept form. Slope-intercept form of a linear equation is this, y equals mx plus b form. When your equation is solved for y, and then you have some m value times x on the right, and then a b value on the left. Well, it's for you to know that the m stands for slope. So whenever it's in this form, the number or fraction or decimal in front of the x is the slope. The slope is not that number and the x. It's just the number, fraction, or decimal in front of the x. The b value, that's going to be some constant, right? It'll be an integer, a decimal, or maybe even a fraction, but usually it's just some whole number. But this is the y-intercept. Sometimes they'll say, okay, what's the y-intercept? If that number, let's say, is a 5, you'll say y equals 5. Or some teachers might want you to be more specific, and you write it as an ordered pair, 0, comma, whatever that number is. So once you have something already in y equals mx plus b form, slope-intercept form, you can easily pull out the slope and the y-intercept. If for some reason your equation is not in that form, then you have to use your algebra to solve for y and put it in that form. Let's say we're told to find the slope and y-intercept of each line. So for example, our first line, equation of a line is y equals 2x plus 1. So we're told to find the slope and the y-intercept. Well, as I said previously, the easy way for you to find the slope and the y-intercept is if your equation is in slope-intercept form, y equals mx plus b. Just commit that to memorization, and then when you're taking a test, doing a quiz, some type of homework assignment, classwork, you just jot that down at the top of your paper, y equals mx plus b. Tell yourself that the m is the slope, the b is the y-intercept. So looking at our example over here, to me, that looks like it's in y equals mx plus b form, right? That's the y, that's the mx, and then that's the b. It's already in that form. So you can just go ahead and write the answer and say the slope is 2, and the y-intercept, I'll just write int for short, is going to be positive 1. Or, as I was saying earlier, some teachers want you to write the ordered pair because that y-intercept is a point. It's a point where your graph crosses the y-axis, and it crosses at 0, 1. Sometimes, to go a little bit further, when you start to graph using the slope and y-intercept, you want to write your slope as a fraction. So to write 2 as a fraction, you would just write 2 over 1. 2 over 1. Okay, so let's take a look at another example, same instructions. Find the slope and the y-intercept of each line. So here we're given y is equal to negative 1/3 x minus 2. So again, I'm thinking to myself, slope-intercept form. So I dump this information from my brain. So usually sometimes when I'm taking a math test, I just do a quick information dump. Dump down all of my formulas, all of my different definitions that I need, and I just dump it down onto the paper. Y equals mx plus b, where the m is the slope, the b is the y-intercept. So to me, this looks like, again, it's already in that form. It's solved for y, and then I have the m times the x, and then plus the b. It says plus the b, so it's plus the minus 2. Doesn't have to say be the actual plus sign in front of it. So then I can just say to myself, what's the slope? The slope is the negative 1/3. And then the y-intercept, or you can call it just the b, if your teacher wants that, is negative 2. Is negative 2. Or, I write negative 2 this time. Or some teachers want you to be more specific and say, what's the ordered pair? What's the point? The actual point is 0, negative 2, right? Because that's where it crosses the y-axis. So as long as it's solved for y, then you can identify the m and the b, the slope and the y-intercept. All right, trying another quick example. Y equals 9 minus 3x. So again, you need to dump down the information, slope-intercept form, which is y equals mx plus b. So commit it to memory, and then say to yourself, the m is the slope, the b is the y-intercept. Well, does this look like y equals mx plus b? Almost, right? The y is by itself. This time, it's not in the correct order. I mean, we can look at this and know that the 3 is the M and the 9 is the B, but for me, I just want to just put it in the right order. So as long as it's on the same side of the equal sign, I can rearrange it as long as I don't change the signs either, right? So it's a negative 3x, I write negative 3x. When there's no sign in front of a number, we know it's positive, so I write positive 9. So now this looks more like, for me, y equals mx plus b, right? Looks just like that now, right? So we know that the slope is negative 3 and the y-intercept is going to be the 9, the b. So 0 comma positive 9. So y equals mx plus b. We have the slope and the y-intercept. So sometimes they'll try to trick you and then rearrange things, but you know and I know that the number in front of the x is the slope and the integer that's by itself, that 9 is the b, as long as it's solved for y, as long as you solve for y. All right, in trying another one, we have negative 3x plus y is equal to 8. Find the slope and y-intercept. So again, the only way you can find the slope and y-intercept is if you solve for y, if you have it in y equals mx plus b form. Y equals mx plus b form. So they'll even throw something like this at you, and some people will automatically say, okay, the number in front of the x is the slope, but that's not right. You have to solve for y first. You have to solve for y, so y must be by itself. So to get the y by itself, I need to get rid of the minus 3x, so I do the opposite, plus 3x, and then this leaves me y, right? And then I'm not adding 3x to the 8. They're not like terms. I'm just moving. I added the 3x just so I can move it to this other side. So I have 3x. And then what kind of 8 is it? It's positive 8 because there's no sign in front of it. So now, doesn't this look like y equals mx plus b form? Yes. So I can say that the slope is 3. Or if I were graphing, I would make it 3 over 1 because we need something that I'll talk about later called the rise over run. And then the y-intercept is equal to 8, or more specifically 0 comma 8 in parentheses. So let's go deeper into this slope thing a little bit, right? So we were taught that slope is the rise over the run, rise over the run. But understand that slope is rise over the run. Rise doesn't just mean up. Rise means up or down direction. Run is left or right direction. Okay, so when we're given the slope, once we pull the slope out of an equation in slope-intercept form, we pulled some out earlier. They were whole numbers and maybe one was a fraction. So if we want to make all of them a fraction, to make a whole number a fraction, just put it over 1. But rise, the numerator tells you how many units to go up or down. If the numerator is positive, we go up. If it's negative, we go down. If the if the denominator is positive, we go to the right. If it's negative, we go to the left. So for instance, let's say we had a slope of negative 3 over 5. What does that mean? It means first, and I'll show you this in a minute, you first plot the y-intercept, but then from the y-intercept, you go down 3, and you go to the right 5. Down 3 and to the right 5, right? Let's try another one. Let's say if I had, let's see, slope is equal to 7. Well, remember I said you always want to make your slope a fraction, so we will make 7 over 1. And the 7 is positive, so from the y-intercept we will go up 7, and we will go to the right 1. Right? And then lastly, let's try one more. Let's say we had the slope is equal to 4 over negative 3. Well, the numerator is the rise, the up and down movement, so we go up 4 from the y-intercept, and then from that up 4 movement, we will go to the left 3 because it's negative. All right, so now let's use the information that we've been using, the slope and the y-intercept, and what I just told you to actually graph some equations. We're going to graph equations on the xy axis. So let's say they gave us y equals 2x minus 3. So first thing you say, is it solved for y? That's the first thing you want to do. If not, you have to algebraically solve for y. But it's already solved for y, so therefore, if it's solved for y, we dump our information down and we say, okay, slope-intercept form. M is the slope, the b is the y-intercept. So the m is the slope, which is 2. And remember, when we're graphing, you want to make a fraction so you can do the rise over the run. So the rise is 2, the run is 1. And then the y-intercept is negative 3. So that's where you go. And that's why some teachers like to write the order pair. Whatever they choose to do is fine. The y-intercept is negative 3. That's where your graph will cross the y-axis. That's the first point you start out with, 0, negative 3. So you go to 0, negative 3, if we say that this is the center, the origin right here. And just know that all of these lines are 1. So you go down 1, 2, 3. 0, negative 3 is right there. All right, 0, negative 3. I'm sorry, 1, 2. Let's try that again. 1, 2, 1, 2, 3. 0, negative 3 is right there. 0, negative 3. All right, and now that's the first thing you do. Start from the origin and then graph your y-intercept. And now you go with the slope. What's the slope? Well, I said that since it's positive, we're going to go up 2. Then since the denominator is positive, we go to the right 1. So you don't start over. You go right back to where the y-intercept is. That's 0, negative 3. And we're going to go up 1, 2, and then hold your pencil, and then go to the right 1, and then make your second large dot. And now you just connect the dots. All right? Connect the dots. And this, I'll label the graph. This is the graph y equals 2x minus 3. So if you have a graphing calculator, you would type that into your graphing calculator, and the graphing calculator would have this exact line. Of course, it'd be much more straight, right? Because I don't have a straight edge that I'm using on this tablet. Or if you use some online software, I recommend Desmos.com. Desmos.com. When you're graphing, type that in, it'll give you the same graph. It'll verify it for you. Here's our next example. We're told to graph, right? Y is equal to negative 3/4 x minus 5. So the first thing you do is dump your information down, knowing that you need to use y equals mx plus b, y equals mx plus b form, slope-intercept form, knowing that the m is the slope, the b is the y-intercept. So you look at your problem, you say, is this already in that form? So luckily, yes, it's already solved for y. Y equals, that's the m, and that's the b, right? Y equals mx plus b. It's in that form. So our slope is negative 3/4 x. So you see how the negative sign is right here, right next to the fraction. It's not really in the numerator or the denominator. So it's up to you to choose where to put it. You can put it in the numerator or in the denominator, but not in both. And you'll still come up with the same answer. You can put it in the numerator or the denominator, but not in both when it's in the side of the fraction. If they already had it in the numerator, keep it there. Or if they already had it in the denominator, keep it there. But it's not. So you choose. And again, you'll come up with the same answer whether you choose to put it in the numerator or the denominator. So I'm just going to put it in the numerator as a negative 3 over 4. That's my slope. And then my y-intercept is equal to negative 5. Or, again, some teachers write 0, negative 5. So that's the first thing you're going to do is plot 0, negative 5. Right? 0, negative 5. So where's that? If this is the origin, we go down 1. From the origin, we go down 1, 2, 3, 4, 5 to negative 5. Make our dot. 1, 2, 3, 4, 5. Make our dot. 0, negative 5. So that's that point. And then now we're going to use the slope, right? So it's a negative 3. So that means we go down 3 because just keep telling yourself the numerator is up and down, up and down. The denominator is left and right, left and right. So we're going to go down 3. And then this is a positive 4. So we're going to go to the right 4, right? Because up is positive, down is negative, to the right is positive, to the left is negative. So that's why we're going down 3 and to the right 4. So from that y-intercept point, right, you never start over. You're going to go down 3. So we're going to go 1, 2, 3. Hold your pencil, and then over 4. 1, 2, 3, 4. And make your other dot. And now you just connect the dots. Connect the dots. And this is the graph of the line. Y is equal to negative 3/4 x minus 5. Okay, so last one like this, we're told to graph again. We're told to graph. So we know that we have to have it in y equals mx plus b form. We always have to have it in y equals mx plus b form. When we pull out the slope and the y-intercept, when we go to graph, because we need the slope and the y-intercept, and then when you eventually begin to compare two equations to see if the slopes are the same, you have to put it in this form so you can pull out the slope. So right now, looking at that, that's not in y equals mx plus b form because the y is not by itself. It has the 3x next to it. So we need to get rid of that 3x. So we do the opposite of the plus 3x. We know it's positive because there's no sign in front of it. So we subtract 3x. So we get negative y is equal to, and you're not subtracting 3x from the 6 because they're not like terms. You're just subtracting it so you can move it over to that right side of the equal sign. And then you see that y equals mx plus b form doesn't have any negative sign in front of it. So if you're solving for y, don't just stop after you've gotten y by itself and there's still a negative. You can't have a negative. So what can you do? You can just multiply everything by -1, or you can divide everything by -1. Doesn't matter, your choice. So to get rid of the negative, I'm just going to divide by -1. I get y is equal to -1 into a -3 makes a positive 3. And don't forget your x. -1 into a positive 6 makes a negative 6. All right, so now we can say, okay, now it's y equals mx plus b form. So the slope is 3. But remember, you want a fraction, so put it over 1. And then the y-intercept is -6. Or some teachers rather you do 0, -6. So either way, you go to 0, -6, right? So let's say that's the origin right there. So you go to 0, -6. So 1, 2, 3, 4, 5, 6, and make your dot. Go to 0, -6 and make your dot. All right. So from 0, -6, let's label that. You go up 3 and to the right 1 because we said positive for the numerator. Positive is up. Negative numerator would be go down. For the denominator, positive is to the right. A negative denominator would mean go to the left. So we're going to go up 3 and over 1. So from the y-intercept, not starting over, you go 1, 2, 3, and then over to the right 1 and make your dot. All right, and then just connect the dots. Make sure you draw arrows on them because the line is going on forever and ever in both directions. So this is the graph of the line 3x minus y equals 6. So see how you had to first put it in slope-intercept form by solving for y, and know that slope-intercept form could not have a negative sign in front of it. So we had to divide both sides by -1, or you could have multiplied both sides by -1. We had to make the slope a fraction by putting it over 1, and then we graphed using the y-intercept and the slope. Lastly, we're going to look at two equations of a line and see if they're parallel. We're going to show that the two lines are parallel. So first we're looking at 2x minus 3y equals 7, and we're looking at negative 2x plus 3y equals 4. We want to see if they are parallel. So we know that parallel lines have the same slope. Parallel lines have the same slope, the exact same slope, right? They may have different y-intercepts, and that's fine, and they should, right? Because they're going to cross the y-axis at different places. But they should be running at that same angle, that same slant, that same slope, right? They should be running at that same gradient. So, therefore, they should have the same slope. So you have to actually test it out. How do you find out if they have the same slope? Well, remember, everything focuses in on slope-intercept form. You have to solve them for y if they're not already solved for y, and then you check out and inspect their slopes. So that's what we're going to do. We're going to do that for 2x minus 3y equals 7, and we're going to do it for negative 2x plus 3y equals 4. So let's go ahead and solve for y. So to solve for y, we need to get negative 3y by itself. So we subtract 2x. Subtract 2x. So we get negative 3y is equal to negative 2x plus 7. So now we have to get the y by itself. So we divide by negative 3. Divide by negative 3. So that leaves us y is equal to, and now 2 divided by 3, 3 doesn't go into 2, so you just leave it as a fraction. And then make sure you get your signs right. Always look at the signs. Negative into negative makes it a positive 2 over 3. And don't forget the x. 3 doesn't go evenly into 7, so let's just leave it as a fraction, as 7/3. But negative into positive makes it a negative 7/3. Alright, so now that's in y equals mx plus b form, so we can clearly see the slope in the y-intercept, but we're going to come back and inspect that in a minute. Let's do the other one. So we want to get y by itself, so we have to get 3y by itself first. So we add 2x, you always do the opposite, right? Add 2x. So you're left with 3y is equal to, you're not adding 2x to the 4, they're not like terms, you're just moving it over so it can be in slope-intercept form. So 3y equals 2x plus 4. And now you want to get the y by itself, so divide by the exact number that's next to the variable. So y is equal to 2 divided by 3 is, you can just leave it as a fraction, 2/3. Positive into positive keeps it positive. And then 3 doesn't go evenly into 4, so you can leave it as a fraction, 4/3. And positive into positive keeps that as a positive. So now let's go ahead and inspect the slopes. So if it's in y equals mx plus b form, you look at the slopes on both sides. Look at the slopes on both sides. So to me it looks like that the slope on the left and the right are the same.